Hey guys, this is Carrie, and in this video we're going to be doing homework 3, so this is the answer key. Let f of x be this function where a, b, and c are constants with a greater than 0. Which of the following represents exponential growth? Okay, so this one's a little bit tricky to figure out. Let's try to think about how we might solve this one. So we've looked at exponential functions like this a couple of times. Oftentimes we have things like the initial value is 100 and it's growing by, 8%. So if we start off with a situation like this, we might imagine that the equation would look like y equals 100 times growing by 8% means 100% plus 8%, 1.08 as a decimal. So 100 times 1.08 to the x power. So we might think about this as like a basic overall function or structure. Now this matches up pretty well with the example template that we are given here. The one thing that's different is this plus c. And c is a constant. It's just some number that we're adding to the outside. So plus something. So maybe plus 5 or plus 50 or whatever number we put there. And what we have to remember from one of the previous units here is that because this is an outside addition to our function, this is going to lead to an outside transformation, which is going to shift everything up or down. So we've seen it a couple of times. When you have an exponential function, usually it looks something like this. And if we wanted to, let's see if we can do this. So for an exponential function, what we can do is if we added 50 to it, it might shift everything 50 up. Or if we subtracted an amount from it, we might shift it down. So that's going to move the graph vertically up and down. Okay, so now how do we answer the question? Well, this outside amount just shifts it up or down. So it's not going to make it exponential growth or exponential decay. If it started off growing and it shifts up 50, it's still going to be growing. If it shifts down 50, it's still going to be growing because it's still going to be in the exponential growth shape. However, here, this times 1.08, that's what had to do with the growing. So as long as this is bigger than 100%, it means we're growing. So bigger than 100% would mean this number has to be bigger than 1. If it were less than 1, that would mean we had to have subtracted off a percent, giving us something like 0.92 or whatever. All right, the value of an investment is initially $4,000. If the investment increases in value at a rate of 10% every 2 years, write a formula for the value of the investment v of t as a function of the time t in years. We saw today that this looks like this, 4,000 increasing by 10%, 100% plus 10%. That would give us 110%. And the best wrong answer here is if we put just t in the power. And the reason why that's wrong is we're not increasing by 10% every year, we're increasing by 10% every 2 years. So the number of times that we compound it shouldn't be every 2 years, it should be every 2 years. So we have to figure out if we divide it by 2, how many times it compounds. A student is studying vocabulary words for another language before studying abroad. They initially know 400 vocabulary words, but they notice that every 3 days they forget 24% of the words they know. Because they're forgetting them, this means that they had 100% mastery, and they lost 24% of those words, leaving them with 76% of the words that they know. But they don't do this every day, they do it every 3 days. So it looks like it's going to be t divided by 3. And we wanted a formula for the amount of words they knew, and it looks like this will do it. A rabbit population doubles every 4 weeks. So that means that the population is going to start off with some amount, currently 5 rabbits. And it's going to double every 4 weeks, so we multiply by 2 every t to the 4th power. Multiply by t every 2 to the 4th, t to the... That's a hard one to say. We multiply by 2, t divided by 4 times. So if it's 4 weeks, it doubles once. If it's 8 weeks, it doubles twice. If it's 12 weeks, because it's every 4 weeks, we should divide by 3, and that will tell us that it doubles 3 times. So here it doubles to the power of t divided by 4. All right, so we're going to plug in 98 days. But this is a little bit of a trick question here. 98 days, this was every 4 weeks. So we need to convert 98 days to weeks. So let's do that conversion. So this is 14 weeks. So we have to make sure that when we have things in terms of weeks, we plug in weeks. So we get P of 14 is equal to 5 times 2 to the 14 divided by 4. P of 14 is equal to 5 times 2 to the 14 divided by 4, 56.5. 56.5. So about 56 rabbits. A financial consultant notices that the value of a stock increases by 45% every 6 months. The value of stock is initially $4,000, then write a formula for the value V of t as a function of the time t in months. So V of t is equal to 4,000 increases by 45%, so 1.45 from the 100% plus 45% to the t over 6 because it's every 6 months. So it looks like this is A. The financial consultant's boss asks for the equivalent monthly growth rate of the stock. So this formula is an every 6 months formula. If we want to get the equivalent monthly rate, then what we really want is we want this formula as an every month formula. So if it's an every month formula, it will look like something to just the t power. So we've got to convert it to something that looks like that. So this is our goal. So we start with what we know, the original pink formula. We separate out the variable from the fraction, so this gives us 1 over 6t. And then this part here is just a number. We can compute it. And you could either use a root, or you can actually just use a fractional power like this. And you get 1.064. V of t is equal to 4,000 times 1.064, because this red part is 1.064. And the only power that's left is t, so to the tth power. So it looks like every month, because now this is an every month formula, every month the stock grows by 6.4%. And this is a little counterintuitive, because every 6 months it grows by 45%. But here we go. All right, the value of a high-risk cryptocurrency. So this was really popular a couple of years ago, cryptocurrencies, which were like these online money things that were unregulated and kind of like a possible future of currency. A lot of people invested in them. This one happens to be called I Make Bad Decisions coin and is initially $3,000 per coin. The coin is going to lose value 20% every 4 hours. Then rounded to the nearest tenth of a percent, what is the hourly rate that the currency loses value at? So let's start with the every 4 hours formula. So the value starts at 3,000. It loses, oh, I was almost gaining value. It loses 20%, so that's going to be 100% minus 20%. That would be 80%. So it retains 0.80, 80% of its value every 4 hours. So this will be t over 4. Our goal is to get the hourly rate that the currency loses value at. And so we have to rewrite this as an hourly formula. So that will be something where the formula is just t in the exponent. And so we can take this pink part of the formula and compute that. So 0.946. This pink part becomes 0.946. Let's see if we got that right. 0.946, yep. And then we just have t as the exponent left. So now this is an every hour formula, as opposed to what we had before, which was an every 4 hours formula. And so it looks like the percent here would be retaining 94.6%, which means that we're losing 5.4% every hour. Okay, I hope you guys found this video helpful, and I'll see you in class tomorrow.